rest of today's 7th grade math students. Hope you guys are doing well. Let's jump into our lesson for today. Today we're going to look at ratios and proportions, so please write that in your notes. Also write this in your notes, lesson 7.1 part 1. And I'm not sure what the date is today, but whatever the date is, please write down today's date, okay? So we're going to look today, students, at rates and proportions, okay? Now remember, I am going to go fast, so all that you have to do is pause the video, write things down, and then restart the video if I go too fast, okay? So let's start off with the definition. Let's look at, first of all, what a ratio is, okay? So here we go. A ratio is simply, students, a comparison of two numbers, okay? So you're simply comparing two numbers, all right? So with that in mind, there are three things you need to know. Now, again, students, I'm going to go pretty fast, so you'll have to pause the video, okay, which is fine. So please write this first thing down. They can be written three different ways, so please write that down. Ratios can be written three different ways, okay? So they can be written with the word 2, and you would read that, you would say, if you were reading that, you would say 4 to 6 is how you would read that, okay? They can also be written with a colon like this, a colon, and you would read that 8 to 16, okay? Or a ratio can also be written as a fraction like this, okay? So you could read this, you could say 21 to 15 if you wanted to, or I have no problem with you saying 21 over 15, okay? So there's three different ways you can write ratios: with the word 2, with a colon, or you can write a ratio as a fraction, okay? All right, number 2, they're usually reduced to the lowest terms. So, just like a fraction can be reduced, ratio should also be reduced, okay? So, look at this ratio here. Obviously, it can be reduced because 2 goes into both of those numbers. So, students, just like if this was a fraction, if 2 goes into both of these numbers, 2 goes into this 2 times, 2 goes into 6 3 times, so you would reduce this to 2 to 3. Okay, so understand ratios are usually reduced to lowest terms. Okay, now let's look at 8/16 here. 8 goes into both of those numbers. Okay, now if you want to use a 2, you could use a 2 and then use a 2 again, and then 2 would go into this, and then 2 would go into 4. Okay, you could do it the long way, or you could just 8 goes into 8, and 8 goes into 16 2 times. So your new ratio is 1 to 2. Okay, now 21 over 15. Let's see, 3 goes into both those numbers, so 3 goes into 21 7 times, and 3 goes into 15 5 times. So this ratio here should be reduced down to 7/5. Okay, so ratios can be written three different ways. They're usually reduced. I misspelled that word, sorry, there shouldn't be a T there, sorry about that. Reduced, okay? And then number 3, they're usually written with whole numbers, okay? I hope you're taking really good notes on this. For example, if I gave you a ratio like this, notice I have a whole number here, but I don't have a whole number here. So, does this make sense, guys? Watch. Here, we took these ratios, and what did we do to them? We shrunk them down. We reduced them. Well, it makes sense. You can also take a ratio like this, and you can, since I have a fraction, I can make it bigger. I can enlarge both numbers so that my fraction is gone. So think about it, guys. Up here, I divided by 2, divided by 8, divided by 3. So now I'm going to do the opposite. Now I'm going to multiply. Now you say, Mr. Earhart, why would you multiply? Because I don't want this fraction. So notice your denominator is 2. Right? So let's multiply this number by 2. But guys, in a ratio, if you multiply one number by 2, you must multiply the other number by 2 also, okay, to keep it equal. So over here, notice your 2's cancel, okay, 2's cancel. 1 times 1 is 1, 1 times 1 is 1, so you have 1 over 1, which is really 1. Now over here we have 5 times 2, which is 10. Got it? So this ratio here that you started with, 1/2 to 5, is the exact same ratio as 1 to 10, but notice now the fraction is gone. Okay, let's try another one. All right, so here's a ratio. So let's rewrite this. Now notice here it's written in fraction form, like 21 over 15. I have 3/4 over 5/3. So I'm going to rewrite it with a colon. Okay, so here's my 3/4 right here. Take good notes of this, guys. Write all this stuff down. Okay, here's your 5/3 here. Now I want to expand or enlarge my ratio so that the fractions are gone. Okay, so you're thinking, Mr. Earhart, over here my denominator was 2, right? So I multiplied by 2, but over here I have 2 fractions. So do I multiply by 4 or do I multiply by 3? Let's do both. 4 times 3 is 12, so let's multiply by 12. Okay, makes sense. So instead of multiplying by 4 or 3, we're going to multiply by 4 and 3. 4 times 3 is 12, so let's use 12. Okay, so I multiply this side here by 12, but you guys know if I multiply one side by 12, I have to multiply the other side of the ratio by 12 too. Now watch how the 4 and 12 cancel. Watch. Okay, watch carefully. Okay, my 4 goes into 12 3 times. Right. 3 times 3 is 9. 1 times 1 is 1. So I have 9 over 1. Now over here, watch your 3 and your 12. Your 3 cancels into your 12 4 times. Okay. 5 times 4 is 20. 1 times 1 is 1. So I have 20 over 1. Okay, and of course, 9 over 1 is just 9, and 20 over 1 is just 20. So there we go. This ratio right here that I started off with, right here, this ratio right here that I started off with is the exact same ratio as this. They are the same, but this one here doesn't have any fractions, so this is the one that I want to use. Okay, so I've taught you how to write ratios 3 different ways. I've taught you how to reduce them, and then I've taught you when one of your numbers in the ratio is a fraction or both of them. I've taught you how to get rid of your fractions. Okay, now moving on. Why don't you guys practice this? Okay, so on your own, pause the video, reduce this, and then turn it back on and see if you got it right. Okay, you should have gotten this. Okay, 7 goes into 7 once, and 7 goes into 14 twice. Now, students, I want you to pause the video and write this ratio here 2 more ways. Remember, I taught you 3 ways to write it, so write this ratio 2 more ways, and then turn the video on and see if you, then start the video, restart it, and see if you got it right. Okay, you should have gotten 1/2 if you wrote it like a fraction, and you should have gotten this. Okay? Alright, let's try another one. Okay, now 8-6. So students, on your own, pause the video, reduce this, and then restart it. Okay, you should have gotten 4/3. Now pause the video, students, on your own. Write this ratio 2 more ways. Okay? Go ahead and do that now. Pause the video and write this 2 more ways. Okay, you should have gotten 4-3 and 4-3. Okay? Alright, let's try another one. Okay, so now I want you to take this ratio. Notice one of your numbers in your ratio is a fraction. We don't want that, okay? So I want you to, on your own, I want you to pause the video, multiply by a certain number, and rewrite your ratio so that it has no fractions, okay? Pause the video and do that now. Okay, guys, so you should have multiplied by 4. What you do to one side, you have to do to the other side. You should have seen that your 4's cancel, leaving you with 1/1, which is just 1. And then 6 times 4 is 24. Okay, that's what you should have gotten. Now pause the video and write this 2 more ways, and then restart the video and check your answer. Okay, you should have gotten this and this. So guys, I hope this is making sense. Okay, let's move on. Now, we're not in class, and I realize that, but real quick here, usually in our 7th grade math classroom, we have 3 males, that includes me, and 4 females, right? Which means our total population in the classroom is 7. Okay? So I want us to write some ratios. So students, using this information here, let's write some ratios. Okay? Feel free to work at or watch me. It's up to you. So write the ratio of males to females. Now males came first, so you put 3 first. Females came second, so you write female second, and you can use a colon, or you could use the word 2, or you could write it like a fraction. However, if you turn these numbers around, that's wrong. Okay? You have to write the ratio in order that it's given. So males to females, the 3 has to come first. Does that make sense? Let's try another one, okay? Let's try this one here. Alright, so let's try. Actually, let me go back. Let me copy this so we have it. And here we go. Alright, so now write the ratio of females to males. So females came first, that's 4. Males came second, that's 3. So you could write it like this, or you could write it like this, or you could write it like this. Okay? Alright, let's try another one here. Feel free to work ahead if you want, and then see if you got it right, or just work with me, whatever you want to do. So now I want you to write the ratio of males to the total population. Okay, so males comes first, that would be 3, and the total population is 7. So you could write your ratio like that, or you could write it like this, or you could write it like this. Okay? And then one more, and we'll move on to something else. Okay? So you can work ahead or watch me, that's up to you. Write the ratio of females to total population. So females came first, that would be 4, and then total population is 7. So you could write your answer like that, or like that, or like that. Okay? Hope that makes sense. Alright, let's move on. Now, students, let's move on. Remember, students, we've been talking about ratios, okay? And now we're going to switch topics. If you'll think back to the very first slide I gave you, I told you we're going to talk about what? Ratios and proportions, okay? So we've talked about ratios, and now we're going to talk about proportions, all right? So here we go. Let's talk about proportions. Now, first of all, it's always good to write a definition, so please copy this definition, okay? You have a proportion when two ratios are equal to each other, okay? So that's when you have a proportion. A proportion has two ratios and they're equal to each other. Okay, for example, here's a ratio. Okay, students, and then 6/15 is a ratio and they're equal. So this whole thing, here's a ratio here, here's a ratio here, and they're set equal. Now, are they truly equal? Well, sure they are, guys. If you were to take 6/15, and if you were to reduce that fraction, 3 goes into 6 2 times, 3 goes into 15 5 times. If you were to reduce 6/15, what would you get? 2/5. So yes, they're equal. So this entire thing here is called a proportion, okay? Because I have two ratios, 1, 2, and they're set equal to each other, okay? Now, that's a proportion. But guys, also, oh, by the way, don't get confused, Mr. Earhart. You can't have fractions. Now, hold on a second, okay? I said you can't have fractions in a what? Ratio. This is a ratio. And I don't have fractions. I have a 2, that's a whole number, and I have a 5, that's a whole number. So this ratio here does not have two fractions, it has two whole numbers. This is a ratio. It does not have two fractions, it has two whole numbers. Okay? Now, you could also say this. Remember, this is a ratio, so you can write it like this, and you could say it equals, and then write this like this. This is also a proportion. Okay? Got it? Because you can write your ratio here with a colon, and you can write your ratio here with a colon. Okay? Now, how else can we write a ratio? With the word what, remember? 2. So we could also say 2 to 5 equals 6 to 15. Okay? And that would also be a proportion. So anytime you have two ratios set equal to each other, as long as they're truly equal, then you have a proportion. Okay? Now, there's some more stuff I've got to show you. Let's take some really good notes. Please write this down. The 2 and the 15 are called the extremes. Please write that down. This is red letters here, and I've circled the numbers in red for you. Okay? So, when you have a proportion and your ratios are written as fractions here and here, this top number here and this bottom number here are called extremes. Or you can say the first number here and the last number here are called extremes. Or you can say the first number here and the last number here are called extremes. Please take really good notes on this. Please write all this down. I know I'm going fast, and I know you're going to have to pause the video a lot, but that's okay. Now, guys, look at the blue. Look at the blue. Okay? The 5 and the 6 are called the means. So, when you have a proportion is made up of numbers called the extremes and the means. The means and the extremes. Okay? So, if your proportion is written with a ratio here is a fraction and a ratio here is a fraction, then this number here bottom left going up to the top right, these numbers here are always called the means, or the inside numbers are always called the means. Okay? You need to know that. Now, I'm moving on, but Now, I want you quickly to pause the video, please, and write down for me the two numbers that are the means. Use your notes if you need to. Are these two numbers the means, or are these two numbers the means? So pause the video and write down the means for me. Okay, you should have written this. Okay, now pause the video, please, and write down the two numbers that are the extremes. Okay, you should have written this. Let's do it again. Let's practice. Okay, so pause the video, please, and write down the two numbers that are the means. Okay, you should have gotten those two numbers. They are the inside numbers. Okay, now please pause the video and write down the two extremes. Okay, you should have gotten those two numbers there. All right, let's practice one more time using ratios that are written with a colon, okay? So here we go. Now, I guess I didn't. Let's go ahead and make one up. So 5 to 7 equals 10 to 14, okay? Please pause the video and write down the means. Okay, students, you should have written down these two numbers here, 7 and 10. Now, please pause the video and write down the two extremes. Okay, students, you should have written down these two numbers here, 5 and 14. Now, here's why it's important. You know what these things are, the means and the extremes. Here's why it's important. Write this in your notes, please. The product, that means multiply, of the means will always equal the product, that means multiply, of the extremes. So when you multiply the means together, and when you multiply the extremes together, you will get out the same number. Let me say that again. When you multiply the means together and multiply the extremes together, you will always get out the same number. Okay? So here we go. This was in your notes earlier. Okay, look back at your notes. Back here. Okay, it was right here. Okay? So, watch this. Here's your means, right? Multiply them together and look what you get. 36. Now here's your extremes. Multiply them together and look what you get. 36. Notice we have the same number. That, students, will always happen. Okay? Let's look at the other example I gave you right here. That was earlier in your notes. You have this written in your notes earlier. Okay? So here's your means, 40 and 3. When you multiply them together, you get 120. Now here's your extremes right here. When you multiply those together, look what you get, 120. Same number. Got it? So if you have a true proportion, then the product of the means will always equal the product of the extremes. Got it? Now, are these proportions true? Let's check and see. Here we go. Alright, please write this in your notes. I'm giving you a proportion. Here's a ratio. Here's a ratio. They're set equal. But is this truly a proportion? Let's see. What did I just teach you to do? Let's multiply our extremes. And when you multiply them, you get 56. Okay, take some good notes on this. Now, multiply your means, and you'll get 56. So, yes or no, when you did your multiplication, did these two numbers match? Yes. So, is this a true proportion? Yes. This is a true proportion. Now, I want you to try one on your own, okay? So, I'm asking you this question. I'm asking you, is this proportion right here, is that proportion a true proportion? Okay? So, pause the video, do your multiplication, turn it back on, and see if your answer is right, either yes or no. Okay, students, here we go. It really doesn't matter what you multiply first, your means or your extremes. I'm going to start off with my means, okay? So my means are the inside numbers right here, okay? So 2 times 36 would be 72, okay? Now your extremes would be 9 times 6. 9 times 6 is 54. Did these two numbers match up right here? No. So, is this proportion really a proportion? Is it a true proportion? No, it is not. Okay? And that's it, guys. So, a quick 30-second review. We've looked at ratios and proportions today. I've taught you 3 things about them. How to write them 3 different ways, how to reduce them to lowest terms, and how to get rid of a fraction if you have a fraction in your ratio, okay? And then we talked about the means and the extremes. Well, we talked about reducing, of course, we practiced a little bit. And then we talked about the means and the extremes, okay? And so understand that you have a proportion when you have 2 ratios that equal. Okay, there's different ways to write it. And then we talked about the extremes and the means. And then when you multiply your extremes together and your means together, you will get out the same number, like right here. 5 times 6 is 30. 2 times 15 is 30. So yes, this is a true proportion. Okay? So guys, that's all for today. I hope this video has been a help to you. If you have any questions, don't hesitate